Now let's see a very important concept that is called transformation of the independent variable. See, what we do when we sit in a car, we apply the pedal or the brake pedal. What happens? We are doing a mechanical, we are applying mechanical energy. Somewhere down the line there is a electrical converter that converts this mechanical energy into electrical energy. Then that gets conveyed to the brakes. There again a mechanical energy is developed so as to stop the brake. So what I am trying to say is that very often we try to transform the independent variable so as to achieve our purpose. So there are two basic types of transformations. There are thousands of transformations possible, but with respect to time, we use two types of basic transformations. First is called time shifting. Time shifting. What is the meaning of time shifting? Let's say this is our signal xt. This is time. Signal is, this is our signal. Okay. This is our signal. Now time shifting means t minus t0 if I write like this, and t0 is positive. If t0 is positive, this means this shifts to this side. This is t0. Okay. But if t0 is negative, t0 is negative, less than 0, then this shifts to this side. This is t0. That is, signal will be like this, and this is t equal to 0. This is time shifting. Clear? That is, signal shifts to this side or this side. We are talking of time. And what is the meaning of this? Let's say we transmitted a signal, but it reaches the destination after this time. So the signal will be shifted by this gap. There will be a time gap. So this is important to keep in mind so that we are able to analyze it. Now, similar to continuous time signals, we have discrete time signals. It is same there also. If this is n equal to 0, let's say this is our n1, let's say this is at n2, this is n3, this is minus n1, minus n2, just to understand. So if this is at this, so shifting by n1, if we write xn is a signal, and if we write xn minus n, let's say n0, so this will be to this point. If this is n0, then we are shifting the signal to this side when n0 is greater than 0. If it is less than 0, this side. That is, if it reaches by a gap of this much time, then it shifts to this side. That is, we are sending this, but there is a time lag. So if because of this time lag, our signal will be displaced by this. This is the meaning only. Okay. So the first type of transformation is shifting. We also introduce transformations to achieve our purpose. We'll study these things later on so that everything will be clear. The second important thing is called time shifting. Time shifting. To explain this, let's say we want to change this to x alpha t plus beta. Our original signal was xt. So we are shifting it to x alpha t plus beta. Then what we will get? What will be the shape of the signal? Okay. Now beta, you know, we have just discussed it. It is shifting. It is okay, not shifting. That the first one was shifting. This is time scaling. Okay. So beta, we have seen it is time shifting, shifting the time to left side or right hand side of the 0 of the origin. So this you know. What about this? Now, if first case is this alpha, modulus of alpha is less than 1. If it is less than 1, then the signal gets linearly stretched. Our shape of the signal remains same, but it gets linearly stretched. What is the meaning? I am telling you. Let's say our signal is this. Okay. This is our signal. So if this is xt and we have alpha less than 1, that is, let's say we have to see what is x half t. I told you it gets linearly stretched, that is half, so it will become double. This will be up to this, that is the signal will be like this. The shape of the signal is same, but it is linearly stretched. Okay, and if this alpha is greater than 1, then what will happen? It will get compressed, opposite to this. So what will happen if we talk of x2t? This will be just half of this. That is, this will be our new signal. This is x2t. Okay, so if this is less than 1, it is stressed. If this is greater than 1, it is compressed. And so we have seen how to transform this into this. You know what? It depends on the value of alpha. This I have told you. Now, one thing to remember is when you have to transform this into this, first of all, you will do the shifting thing. You'll shift the wave and then you'll scale it. This is the process. You cannot scale and then shift. To tell you, let's say we have xt and we have to find x2t plus 1. So what you will do is, you will first of all find t plus 1 and then you will find x2t plus 1. Okay, this is the way. So let's see some examples so that these things are clear. Let's say our wave is like this. This is 1, this is 2. This is your xt and this is t. Now what you have to find is xt plus 1. Okay. This means advancing the wave, that is here to here. Other way is, let's say this is t0. So now t0 is t plus 1. This means new t is t0 minus 1. That is, we have here we have t0 equal to 0. So this means new t will be 0 minus 1, that is minus 1. That is, this point will shift to minus 1. Okay, so the new wave will be like this. Okay, I'm putting it here. The new wave will be like this. That is, this to minus 1, this is now 0 and this is now 1. This is now xt plus 1. Okay, so this is advancing xt plus 1. Clear? If this was xt minus 1, this means now this t0 is equal to t minus 1. This implies t0 is equal to, t is equal to t0 plus 1. That is, new will be, we had this here, we have advanced. Here we'll have, if it was 0, this will be now 1. So this new curve will be like this. 0 to 1, nothing, and then from 1, this wave will start. 1, 2, 3. Okay. This is xt minus 1, this is xt plus 1. Clear? You can do this also t0 plus 1. So 0 plus 1, 1. So new origin is at 1. Sorry, new start of the wave is at 1, which was at 0 here. Clear? Now, let's see. This was about shifting. Let's see a simple example about scaling. Let's say we have this graph. This is at 1, this is 2, this is 0, xt. We want to know what is x3 by 2t. Okay, so I told you, you just put t0 equal to 3 by 2t. This means our t will be compressed by this much, 2 by 3 of t0. The shape of the wave will remain same. It will just compress the wave because this is greater than 1. This is greater than 1. You have studied, if alpha is greater than 1, it will compress. If it is less than 1, it will expand. So now this is, so 0 to 1 will now become 2 by 3. It will compress to this point. Let's say this is 2 by 3. So it will compress to this point. Similarly here also, from here to here. So our new wave will be like this. The shape of the wave will be same, but this point will be 2 by 3 and this will be into 2. So this will be 4 by 3. This is our x3 by 2t. Okay? Clear? Similarly, if we have to find x2t, let's say we have to find x2t, 2t. So our new, this will be 2t. So t will be half of t0. So this will be reduced by half, compressed by half. So our new wave will be like this. This will be at half and this will be 1, x2t. Okay, clear? If you want to have x4t, so similarly this will be the shape will be same. This will be 1 by 4 and this will be 2 by 4, that is 1 by 2. This is x4t. Clear? Let's see some examples on expansion, that is alpha less than 1. So let's say we have to find this half t. We know this is our t. Then, so what we'll do? t0 is equal to half of t. This means t is equal to 2t0. So initially it was 1, now it will be 2. So our new wave will be, the shape of the wave will be x half of t. The shape will be same. The only thing is this is now 2 and this is now 4. Or if you maintain the scale, then this will be like this. This is your now new point. So this will expand like this. Okay, this is 4, this is 2. So this way will be like this. Clear? One more example. Let's say we have to find x 1 by 3 of t. So our t0 is 1 by 3t. So new t will be thrice of t0. This was 1, so it will be 3. So I am doing on a scale only. 2, so this will be 3. This is 3. So our wave will be like this. This and this up to 6. Clear? So I think these things are clear to you. Now we'll see how can we have scaling and shifting together. I told you x t plus 1 here will be like this. Okay, so this is 0, this is 1, this is minus 1. This is xt plus 1. Now, what if we have to find x 2t plus 1? 2t, you saw it will compress. So, first of all, what you will do, you will take xt plus 1, this wave, and then you will compress the time. This is twice, so this will half the original wave. So, now this will be like this. Our new wave will be like this. Half, that is minus half, this is plus half. This is x 2t plus 1. Clear? Again, we have to see x, last time we saw 3 by 2. So x 3 by 2 t plus 1. So first thing what we'll do? We'll do the shifting part. We'll shift it so that our new wave is like this, 1 minus 1. And then we'll do the compression part. So new wave will be this. This is 2 by 3. This is minus 2 by 3. Okay. So our new wave, that is x 3 by 2 t plus 1 will be like this. Minus 2 by 3, 2 by 3. First of all, what we did? We did shifting and then we did scaling. Let's see one expansion example. Let's say we have to see half t plus 1. So again, what we'll do? First of all, we'll shift it. So this is 1 minus 1. Okay. This is xt plus 1 and then this is half t. So this will expand. So our new wave will be this 2 and here let's say this is the point minus 2. Okay. So new wave will be like this, minus 2 plus 2. Clear? I think I have given I think we have discussed so many examples. Shifting and scaling must be very clear to you. Okay. Now let's understand, or to say let's revise what are periodic signals. You must have studied periodicity in your 11th, 12th classes. Let's have a recap. If we have a signal which repeats itself after certain time t, then this is a periodic signal. That is xt plus t is xt. Graphically, if let's say this is t, okay, this is t, and our signal is like this. So every t it repeats itself. A very common example is sine and cos wave. So this is pi, this is 2 pi. So after every 2 pi it repeats. So time period is 2 pi here for sine or cosine wave. This is periodicity. Clear? So xt plus t is xt. That is after this time interval we get the same wave. Okay. What is fundamental time period or fundamental frequency? The lowest value of t for which this equation holds true. That is, let me explain you. If you said 2t is also a time period, because after 2t it repeats itself. That is, if you have a sine or cosine wave, after 4 pi or after 6 pi or 8 pi, the wave is identical. After 8 pi also the same wave is, you will find the same wave. So these all are time periods, but the lowest time period for which this equation holds true, that is xt plus t equal to xt, that is called fundamental time period, and for time period it is the frequency, reverse is the frequency. So in case of sine and cosine, this is 2 pi. Okay, clear what is t, what is fundamental time period, t0. In case of discrete time signals, it's same. The representation is like this. We say n after every n number of signals. If it is same, then we say it is a periodic signal, periodic discrete signal. That is, let's say we have 1, 2, 3, 4, and then again 1, 2, 3, 4, 1, 2, 3, 4. So this is repeating. Let this be n. So this is repeating after every n number of discrete points. So this is a periodic signal. Clear? Discrete periodic signal. Now, from here only we have a concept of even and odd signals. What are even signals? Even signals are those where if we have x minus t equal to xt, or in terms of discrete signal, if this is, then we say it is an even signal. That is, let's say I'm putting it like this. In continuous time, first of all understand for continuous time, then you will get for discrete time. If our signal is like this, okay, this is 0, this is t, this is xt, x minus t will be this. So if we have a mirror image here, this is not to scale, if we have a mirror image here, this to this, that is at x equal to t and at x equal to minus t we have the same value, this is called an even signal. Clear? So similarly, in case of discrete signal, if let's say this is 0, if this is the signal, and here also we have same thing, repetition, that is even signal. Clear? Similar to this, we have odd signals. Odd signals are that it is actually negative of its value, that is x minus t is equal to minus of xt. There we had same. Similarly, we have x minus n equal to minus of xn. So in graph, how we can say? Graphically we'll understand like this. If this is our signal, so here we'll have this one, like, see, inversion. This is xt. Okay, so minus at t equal to t0, the value we will have exactly minus of this value at x equal to minus t0. Okay, and similarly for discrete signal, let's say this is 0 point, and if we have this signal, then here we have like this. Maybe not, this is not in scale, you just understand these are same. If this is 1, this is minus 1. If this is 2, this is minus 2. If this is 3, this is minus 3. If this is 4, this is minus 4. 1, 2, 3, 4. Minus 1, minus 2, sorry, minus 1, minus 2, minus 3, minus 4. This is an odd signal. Clear? We'll use it when we will analyze signals.